You might notice that all those lovely chips that we put in last time have been removed. I did a little bit of testing on this board and discovered that it's got a problem. Basically, the 5 volts and ground are shorted out, and so it doesn't work, and we need to find out why. Okay, there's basically very little or no technical information out there, as far as I can see, about exactly how this board works in terms of the layout and the components and stuff. It's a PET, and we're going to kind of work on that basis. Now, these 4 chips here are MIC 2951 voltage regulators, and they look basically like this. So, little 8-pin chip, and this pin 1 is the output, this pin 8 is the input. That's a sense line, that's a shutdown line, that's ground, that's an error signal, that's a tap, and that's a feedback input. So basically what we have is unregulated DC voltage going in and regulated 5 volts coming out. The tap gives us a 3.3 volt split, or I think 4.85. But we don't need to worry about that, and that goes into the feedback, so it's just a thing. Now, the 4 chips on this board, that one and that one, supply 5 volts to the cassette ports, and that one supplies 5 volts to the monitor output. This one supplies 5 volts to the entire rest of the board. Now, what happens when we put our multimeter, let's turn it on, set it to continuity, there we go, between 5 volts output and ground. Right, okay, let's do it on this one. Nothing. 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 Wah, wah. So somewhere on this board there is a dead short between 5 volts on the main bus line and ground on the main bus line, and we've got to find it, because unless we find it, this board ain't doing nothing. Now, it's not the chips. We've proved that by taking all the chips out, and the short is still there. So something somewhere on this board is shorting. Now, I've had a look over these solder connections, and there doesn't seem to be any obvious bridging that I can see. So maybe something is in backwards. Now, what have we got? We've got this capacitor is clearly the right way around, because the negative arrow points to the negative on the board. These diodes, the bar on the diode, that indicates the cathode is towards the bar on the circuit diagram, or at least on the print screen. Now, everywhere there should be a resistor, there is a resistor. And I've gone through and I've checked the numbers and they are the right values. There, and they all appear to be right, and the capacitors all appear to be right. These are, what are they? 100 nanofarad axial ceramic, that's these little decoupling jobbies, and 22 picofarad axial ceramic. We only have the one electrolytic, and that's the only one that is polarized. This is polarized, the piezoelectric sensor, and that still has the label on it indicating positive, and positive is definitely that side. Doesn't say anything on the back, but that is definitely the positive side. So, is there something on the top of the board that is shorting out? Maybe there's a solder bridge between components. I don't see anything. Of course, when I was cleaning the board, I was concentrating on the bottom of the board, not on the top. Now, some of those I think could do with reflowing, but I don't see anything that looks obviously like a bridge. I think I'm going to reflow those solder joints in any case. And if there's a bridge there that I can't see, that might well resolve it. And then I shall have to think. Maybe there's something under one of these chip sockets. It's very hard to see under the sockets, but I don't think there's anything obvious. The LEDs are the right way around. So that's the flat, that's the flat, that's the flat, that's the flat. The transistor is the right way around. These key switches, the soldering is so far apart, I can't really imagine that there's anything to get shorted. And even if one of the switches was stuck down, then how do these switches work? I imagine that these two resistor packs here are to do with the keyboard, and they're either tying the keys to plus 5 volts or to ground. And I would imagine that, yeah, that shouldn't cause a direct short. I'm going to reflow these components and see where that gets me. So I went through all the soldering on the board, and as I guess is probably expected, that really did nothing. You can't see the whole board from the back. There's no obvious solder bridges, but there were no obvious solder bridges. But I've gone through everything and reflowed it. But of course that showed nothing. So that does not preclude there being issues on the top of the board, and there could be something under one of the chip holders, for example, that we can't see. So the next thing was to go through all of the IC sockets and check every adjacent pin and see if there were any shorts or any connections there that were not to be expected. And this is what we found. Most of the logic chips were clear. There were a few that had connections together. So for example, this 74LS00 has a connection between here and here, and another connection between here and here. And then on these 138s, we've got connections between those pins and that pin. And throughout, all the adjacent pins that I found were reasonably to be expected. So I went and had a look at the pinouts for these chips, because of course we don't have any kind of schematic for this circuit, so we can't look and say, you know, this pin should be connected to this pin. We're kind of going by gut instinct. Looking at the pinouts for these ICs, the 74LS00 is a quad dual input NAND gate, and what we've got connected to each other is the output of one going into the input of another, so that's fine. And the same thing with these address decoders. What we have got tied up is the enable pins, so that's just doing certain address range selection. That's not a problem. The other ICs on the board that had connections, the ROM chips, that was tying up sorry, the ROM chip, that one and that one, that was tying up the programming line, so that's fine. The one IC that did not make much sense was the CRTC, this 164P chip, and these two pins here are shorted together, and as you can see from the pinout, that's VCC and ground. Now this does on the face of it look like a smoking gun, but bear in mind that we know that VCC and ground are shorted out. So what we don't know at the moment is that the cause or is that a symptom? But I think we need to remove this socket and find out. Okay, let's desolder this. You realise this will all look perfect in the edit. It's come out. Hurrah! Okay, well now we've got it out. There are definitely no bridges. So we'll put it back. So that didn't work, and I think at the moment we are back pretty much to square one. Okay, now on a wild hunch, I started pulling up legs of these capacitors to see if there was something that was shorting out underneath them, even though I couldn't see anything on an inspection. And I got to the third one, this one here, and you see I've pulled one leg out. That's actually the positive side leg, and proof positive, we go to move this over so that you can see it. Ground and 5 volts, and there is now no connection. So whatever it was, desoldering that leg has fixed it. Now there's nothing, that capacitor itself is not shorted out. Let's make sure that that's in picture, because you can't see anything with that camera. So there you go. So that's not shorted out. So I think if we put that leg back, hopefully it's going to work. Right, so just solder that last one leg. Okay, so I shouldn't have switched that off really, should I? And across these capacitors there is nothing, so that's good. Let's put the chips back in. Let's put the chips in. But first we'll put our little blue anti-static band on. Okay, now we'll give it another test. Ground of 5 volts. Nope, nothing. Excellent. Let us give it a try. Plug the power in. Here we go. 9-volt light is on. It's not right, but it's not wrong. So we've got ready light, and you see we've got a screen full of stuff. So there's another problem somewhere on the board, but we've got a display. So yay. Okay. I don't know if you can see this. I've zoomed in real close as far as this camera will go. I was having a look on the back of the board, and I noticed on this chip here, some of these pins are actually not soldered. There, and there, and there, and there, and there, and there. So that's obviously from when I went over the board and reflowed everything, and obviously I screwed that one up. Now that is the 65C02, so I've got a suspicion that this might be the cause of our problem. So let's apply some solder. Okay. Right, let's turn it over, plug it in, switch it on. There's the plug, the green power light is on. Let's turn the monitor on. Actually, I'll turn this desk light off because now that's encouraging. Okay, what you're seeing there is a test pattern. If we pan back down to the PET, look at the dip switches, you'll see that they are down, up, down, down, up. Now, here in the manual, there we go, is the test that this is running. So this examines the first and last 1000 bytes of memory and shows the results. Turn the power off, set the dip switches to down, up, down, down, up. Power on, the test cycles between 4 screens. Screen 1 shows 2000 characters indicating each byte of RAM, tested as G for good or B for bad. Screen 2 shows uppercase and lowercase graphics. Screen 3 shows G for good, B for bad in lowercase. Screen 4 shows the lowercase, uppercase character set. So that is clearly what we are getting. Let's run the other test. Now the other test is up, up, down, down, up. And this does system and video RAM. Okay, so let's do that. It doesn't say what the results of that are going to be. Down, up, sorry, up, up, down, down, up. Okay, let's get that right. Turn that on. That does look encouraging. Okay, I'm going to turn it off and I'm going to set all those dip switches to off. So this should now boot as a PET. Look at that. Look at that. That's exactly what we wanted. So let's just go through and make sure that everything works on the keyboard. Okay, and reset. Yes, that works. 4080. Yes, that's in 80 columns. Menu. Device not present error. Okay, that's because we don't have an SD to PET plugged in, or a disk drive plugged in, or a tape drive plugged in, or anything else plugged in for that matter. Okay, now with this kit I bought an SD to PET, and we're going to plug this in. Goes into the IEEE 488 port, and one of the cassette ports will go into cassette 2. You'll see that it says top on the top. And as with the other one, I am going to write T on there so that it is clear, or at least clear to me. Okay, so let's power it back on and switch it on. I'm sure you can guess what's coming. Let's hit the menu button. So now we've got it working, the final thing to do is put the acrylic plates onto the PET. Right, let's take off remove seal after washing. Well, we've washed, so let's take that off. There we go. Now, let's put the bottom plate on first. We have to take the protective film off the acrylic. or Perspex perhaps we should call it. Yeah, it is Perspex. There we go, this is almost as good as popping bubbles in bubble wrap. Look at that. Some really nice black. And the other side. And the top Perspex is the same. Okay, so I'll worry about that later. You don't need to watch me pulling little bits of plastic out. Okay. All that remains is to switch it on. And we will do what we have done with the Commodore 128 and what we will no doubt do with every other computer. PETSCII Robots. Notice how much faster it is on this than it was on the 128/64. Okay, don't forget to like and subscribe. Now, see ya.